So flux density, magnetic flux by area. Okay, so the flux is basically magnetic field into area with cause of the angle, but then that can be approximated to 1 if the flux lines are making an angle which is 0 degrees to the surface. So flux density is equal to VA by A. So flux density is B. And we also try to establish the Ampere's law. And it states that the magnetic field is directly proportional to current. Magnetic field is directly proportional to the inverse of the distance. So the magnetic field collectively is proportional to I by R, and magnetic field is equal to Ki by R, where K is the constant of proportionality and its value is mu naught by 2 pi. Okay, so this becomes mu naught by 2 pi dot I by R. This becomes the form. In a solenoid for a unit length, differential unit length, we have circumference 2 pi r. Since let's say this is the solenoid with inside the circuit, the battery terminals, current, and then there's the solenoid. So we have this law as well: electric field, magnetic field, and I think the third one is force. So there's this like x, y, z, they're on 3 perpendicular directions. But this is ambiguous for now. We will discuss that later. So we get back to our mathematical form. So summation B delta L, you see, so magnetic field into length and summation over the differentials will become B summation differential length, sum of all the lengths. Yes, we have the form for B. So let's say A here, B here. Okay, so B summation differential length uh, becomes equal to Ki by R, which is basically equal to mu naught by 2 pi dot I by r dot 2 pi r, which is the total length. Yes, so r cancels out, 2 pi cancels out as well, so we're left with mu naught I. So what we have here is the form which says that the law of Ampere is the sum of EC summation V. I'll tell you, sum of the product of differential lengths and the magnetic fields, and it's equal to mu naught I. I is the current and mu naught is a constant in this case, which we can discuss later. So B yes, so B summation delta L is equal to mu naught I. So this becomes a form which is the Ampere's law in magnetism. Yes, so now we move on to some other topics in the same domain. Yes, so the next one, let's say, is force. How we approximate force in magnetism. As we know that the magnetic force is equal to I LB sine theta, this we know, and I is also approximately equal to the number of charges, the unit charge by t, charge by time, and multiplied by the number of particles as per particle here. Okay, so, and velocity is distance by time, and distance in this case is length, so v is equal to s by t, means L by t, as S is equal to L, the length of the conductor of the solenoid. S is equal to L. So we have the form L is equal to, Vt is equal to L, implying L is equal to Vt. Okay, so this is the basic version here, and so now we are to substitute I in L, and Q by T and Vt. Okay, so basically as we know that we have this force here, 1, then we have the substitutions here, so let's call this substitution A, and let's call this substitution B. Okay, so now we use these in our force version. So Fb becomes equal to nq by t dot vt dot b sine theta. Okay, okay, so t cancels out here, so we are left with the form in the next step. N v q b sine theta, and if for example n is equal to 1, that's for a unit particle, so the very basic general form would become Fb is equal to vqb sine theta. Okay, we have to keep this in mind as well. Okay, and the other way of going about it is basically I'll rather explain the fundamentals and try and develop a small form, the same one. So Fb is directly proportional to charge. The magnetic force is directly proportional to charge. It's directly proportional to velocity v of the charged particle, and it's of course directly proportional to the magnetic field, the magnetic force. And since it is a vector situation, we can also approximate make it proportional to sine theta, because the product is the vector, it's going to be the vector product in many cases. And if we combine everything, it is proportional. Fb is proportional to v q, once again v q b sine theta. Yes, and Fb is equal to kvqb sine theta, and k is equal to 1 in SI. Fb is equal to vqb sine theta. Okay, so this becomes the equation, and we already know this, but this is another way of approximating the general form. Okay, so if we are supposed to estimate the motion of the charged particle and try to develop a form, yes, so what we will do, I will let you know. Motion of a charge